He'll be the one in charge for this last talk. Once again, I want to thank you all for tuning in and joining React Day New York 2021. And once more, thanks to all on the sponsors that made this happen, and of course, keeping us set everything up. Without further ado, I'll pass it on to you. No more on-screen time for me, Shawn. So it's all yours.
Okay. Click to close message. I am screen sharing. Okay. Stavros, let me know if you can hear me because I'm still not very super confident about this platform.
No, this looks perfect. Your sharing screen.
Awesome.
We have the presentation. It's not presented yet, but it's up there.
All right. So hi everyone. Hello React New York. It is my home town in in the US, and I miss everyone back in New York. I am currently based in Seattle, but I'm here to talk about React for the backend. In 2020, I actually thought that I had given my last React talk because I was all tapped out. I had said everything I wanted to say, and then React New York came by and said, "Do you want to speak?" And I was like, "Oh, I really wanted to speak for React New York." So here's my presentation about what I've been working on and what I think the parallels have been for React. And I think there's some generalizable lessons, even if you don't end up using Temporal. So what the inspiration for this talk came from Guillermo Rauch, actually, the creator of Next.js. And he said, he was the first person to point out that Temporal IO does to backend and infra what React did to front end. Temporal's engine is quite complex, much like React's, but the surface exposed to the developer is a beautiful render function. And I'm a bit upset because he realized this before me, and I have been working on Temporal for a few months now. So important caveats before I start this talk. What I'm presenting to you is alpha for TypeScript. Temporal is typically a Go or Java-based application, but we're developing TypeScript and hopefully launching it soon. And then finally, React for the backend is an analogy, not a design goal. And the way I treat this is like, it's basically like crabs. And one of the most entertaining facts that I've ever found is that nature has apparently tried to evolve crabs 5 independent times. And in fact, there's a word in evolutionary biology for it called carcinization. And of course, this is really good for a lot of memes. So tired conversion evolution is not uncommon, especially when species have similar selecting pressures in their environments. Wired, everything is crab. And perhaps everything is React because we have similar design space problems. So I'll tell a little bit of the story through 3 parts. There's components, and we'll tell it through the story of Uber. We'll talk about architecture, we'll tell it through the story of YouTube, and time, we'll tell it through the story of Amazon. So a lot to cover. I'm gonna try to go really fast. Don't worry, I'll share the slides on my Twitter later on. Okay, so part 1 is about components. You see this a lot on YouTube. Probably you're watching now on YouTube or live streaming. And yeah, you know, like 3-hour live stream, let's clone Uber. Very cool. I think we know how to break things down, and React has really helped us be more productive by being able to break things down into components and knowing how to compose them together in a predictable way. But there's a lot of things unanswered in things like this, in full stack clones of major well-known apps, which is the hard parts. Like a typical Uber trip will have all these steps like search, pricing, match, pickup, drop off, rating, tipping, payment, email, and so on and so forth. And typically the naive way of organizing all this is basically one after the other, right? Like this is search goes to pricing, goes to matching, goes to pickup, goes to drop off, goes to rating, goes to tipping, goes to payment, goes to email. Imagine that these are all managed by separate teams and scaled independently. I think then you realize like this is only the happy path. Then you have to throw in a whole bunch of things that can happen along the way. An Uber trip is basically a long-running process with humans in the loop, and humans are very, very messy by nature. So how would you write an Uber clone? Good luck with a lot of the technologies that you would typically reach for just naively, because you would have to discover all these systems and all these use cases and edge cases along the way. So when people say full stack, they often really mean like this half-drawn horse meme. I think this is particularly funny, so I take every opportunity I can get to show it. But honestly, to be honest, a lot of us front-end developers are probably the other way, the half-drawn dragon, where front-end are very good, and then the back-end will just like, stick some stuff on Firebase or something. And in reality, if you look at the backend systems, most companies, especially at scale, go towards some form of very complex microservice system. And I don't have the chart for Uber, but Halo is probably a good comparison, Netflix, Twitter. And it's not really avoidable. If you want to scale a company to any significant size, you probably have to break them up into independent services because you're going to ship your org chart anyway. But the thing I realized as a React developer, as a front-end developer, is that actually we had a pretty good run in the past 7-8 years of React in terms of the fact that front-end developers know how to organize code, at least in terms of the component level. So we moved from the jQuery era, where everything was just kind of spaghetti all over the place, to at least something more organized, where event handlers are strongly tied, locally tied with vendors, but centrally managed by a React runtime. So a few key lessons from React that I personally draw is that you want to have a components and a renderer model. So essentially the user or the developer writes components, and then the React core team writes the renderer. And that handles a lot of the boilerplate that you might typically forget. And this is everything to do with unmounting or having local state. And it gives you a very nice non-leaky abstraction that you can write. Second, you can also guarantee work and correctness, which is originally what drew Jordan Walk to make something like React, because he was working on Facebook Messenger and there was a lot of inconsistent state within Facebook Manager because of the spaghetti code. So correctness, meaning that we embrace functional programming to produce a virtual DOM. View is a pure function of state. If you look at the old enough React talks, you will see a lot of V equals FD. So view is a pure function of data. And finally, the programming model, we like to say that it's just JavaScript. There's no custom syntax or templating syntax to learn. I think all these three lessons, there are actually a lot more, but all these three lessons are what I'm going to focus on for this talk. And I think whenever you tackle any programming paradigm, any framework, any design question, you might want to run it through some of these ideas. So whenever I talk about React principles, I always like to bring up the fact that there's this often overlooked repo called React Basic, and it's actually in the official React organization on GitHub. And this is Sebastian Markberger, who's the tech lead of React, and he wrote down 6 years ago his principles on what he thinks makes up React on a fundamental basis, no JSX, just like what are the principles that we're designing for? We are designing for a simple, pure transformation, abstraction, composition, state, memorization. The words that he uses are very theoretical sometimes, but you feel it every single day when you write React. So there's a lot of things else apart from that React has done for front-end programming. Apart from deterministic renders, we have use state, we have reduction of boilerplate with the unmounting, child components, and the very careful design of composition, side effects where we have use effect or use memo. And actually, a lot of people don't know. I forget my source. I think it's Sophie Alpert, but 1/3 of the React code base is actually just normalization of events across browsers. So you don't even have to worry about it, and creating synthetic events for that. They also produce a dev tool and they manage a central scheduler. And obviously, the success of React over the past 5-6 years has really shown testament to how great all these decisions have been. If you want to learn more about the talks that I've done and my perspectives on some of these React principles, I've done 3 talks. One is at React Rally, the second at JSConf Asia, and then the third on my own at React Summit. So you can check out my YouTube for more conversations on that. I don't have time here. Okay, so that was part 1, where we talked about the components and the React revolution. So part 2, we're going to talk about architecture. So one level higher than just components. And I'm going to motivate this question with a question of how would you write YouTube? And again, if you look on YouTube for how to write YouTube tutorials, you can get full stack clones of YouTube, which is pretty impressive. Write YouTube in 3 hours using Firebase. That's very impressive. Unfortunately, the hard parts of YouTube also come in, and there are a bunch of YouTube Googlers actually who and actually went and interviewed YouTube engineers on how YouTube works on the back end. There's a bunch of work that goes on in the background. So you need to upload your file, you need to analyze for metadata, you need to split it up into chunks, you need to process these chunks in parallel, and then you need to stitch it back. And by the way, processing, you have to produce an array of formats, right? From 240p to 1400p or something like that. And then you have to stitch all these chunks back into the continuous videos that you actually see in stream. You need to notify subscribers, you need to produce automatic captions, and you need to produce thumbnails. And that is, again, just the happy path, right? So what about all these other features? For example, YouTube Premiere is a scheduled release of a YouTube video, or feeding into the recommendation algorithm. That must be the most craziest batch job in the world. And you need to scale this process, whatever you design, for 30,000 hours of video uploaded every hour. That's the sheer amount of volume that's going on YouTube today, which is just insane. Like any design that you make at scale is going to break in some respect. So I think that's really interesting to consider. And I learned about this actually, and I thought more about this because I interviewed one of our users who is Descript. Descript is a audio transcription platform, and their entire business is transcribing audio and then making it easy for you to edit audio. I do it for my podcasts every single day, and millions of people use it. I think it's really cool. So their problem was that when a user hits transcribe, it kicks off a asynchronous multi-stage and parallelized process that involves re-encoding audio, chunk splitting, external API calls, merging results that may potentially arrive out of order, and then verifying their alignment. So there's a lot of nuance here that can get really tricky. And if any part of the process fails, you need to try it again. So this is typically the kind of architectures that people build up incrementally over time as they discover all these use cases and then find holes and then patch them because it's too late to rewrite something. There's a lot of decisions that goes into here, and this is normal. This is natural. I think you run into basically the 8 fallacies of distributed computing, which is actually discussed or discovered back in 1994 by people at Sun Microsystems. I love these cartoons, but they can be a little bit hard to read. So here's a more organized version of them. And at the bare minimum, don't forget distributed computing fallacy number 1, which is that the network may or may not be reliable, or compute may or may not be reliable. So what that means in practice is that when you're calling system A, B, C, D, E, F, G, you may actually need to introduce hardening layers, because at every point when you cross system boundaries, you have a chance of failure, and that multiplies exponentially as you have more and more services tied up in your systems, like we saw for the Uber example, like we saw for the YouTube example. You need to add in timeouts and retries. And what that means is that you need to persist the number of times you timed out, when you timed out, what jobs you timed out. So you need a database every single time. And then you need a scheduler or a timer to say when the next time is going out, I'm going to try this again. And you need to write this for every service. So if the maintainer for every service needs to maintain both the code and the infrastructure for this. This is a lot of how I was talking about things when I was exploring the serverless world. So here's a real life example from the AWS blog, where they said, okay, we're using did letter queues to replay messages when such things as failures occur. And this is a fine looking example until you try to scale it. And again, it looks like a complete complete jargon. It's very hard to keep in your head. And pretty soon when you're explaining this to your CTO, you look like the Pepe Silva meme. So the solution that I found is really to have a central orchestrator, right? Instead of every single system maintainer writing their own API hardening layer, which is just a production requirement as you find more and more of these bugs, you just centralize it. A centralized team that takes care of the orchestration of all these different services. And that's in the business what we call choreography, which is A to B to C, versus orchestration, which is a central orchestrator coordinating the dance between A, B, and C, and then storing both the infrastructure and the code for the scheduler and the database. So there's a really good article on this by Yan Cui in theburningmonk.com. So I highly recommend checking it out, where he talks about choreography versus orchestration with real life examples that people use in AWS, but also it's not specific to any cloud. It's a architecture design pattern, which I think fundamentally, if you start off with this, it's really hard to re-architect to this. So it's a I mean, it's possible because people are doing it, but also it's a conscious architectural choice that you might not know that you're making if you don't know about it. So I guess a lot of my message here is to tell you that orchestration is a thing. Also, so you want to declaratively put into your framework retries and timeouts. So for example, this is actually our API. You want to be able to say, all right, here's the default retry policy. Whenever I fire off an activity is just like an external API call, for example. So when I fire off an activity, I want it to be retried every second if it fails. I need a backoff coefficient, like exponential backoff. This is very similar to the TCP protocol, so that if the endpoint is failing or getting rate limited, I don't keep retrying and then building up a DDoS attack on myself. I actually back off and put more and more intervals in between until some maximum interval, let's say 100 times 100 seconds. And then I give myself a maximum attempt. So I can say like, all right, I don't want any retries. I can just say I have a maximum attempt of 1. Or let's say I want a linear back off and not exponential for whatever reason, and I want to try a maximum of 5 times. You want to have this all declarative so that you can tweak this as you understand your system and you scale your system, right? So I think this is a really interesting programming model that just puts retries into the code that you write. And that's only possible when you have a centralized orchestrator, no matter what system, not just Temporal. Okay, so the case that I'm making is really for choreography versus orchestration. And the analogy that I make for front end versus back end is that it's kind of like vanilla or jQuery versus React, right? React is the central orchestrator orchestrating all the components. And I think that's a really interesting architectural analogy that you can make and learn from React. All right, part 3, time. I'm doing very good on time. I'm doing better than I thought, which means that we'll have time for a live demo, which is really awesome. So let's talk a little bit about Temporal. What is Temporal? Temporal is the open source platform for orchestrating highly reliable mission critical applications at scale. I love talking a little bit about the history. The reason because our CEO started at Amazon as the tech lead for what became Amazon SQS. Our CTO was at Microsoft, and it was the principal architect of the durable task framework, which became Microsoft's version of durable task functions. And then finally they joined Uber and worked on Cadence, which was the open source version of their workflow orchestration platform. And Cadence became so popular that they spun out and became Temporal. And since then, it's been adopted by a lot of well-known household name companies, especially in the developer world. There are a lot of people hiring for Temporal developers, which I really like to see because it's not just being used, but also it's creating jobs for people and it's becoming a desirable skill set. And most recently, last week, we had Netflix presenting about how they use Temporal for their CI/CD. So I think a really interesting span of like adoption and momentum story. Temporal has 3 components, or it produces 3 products that are used in sync. The main star is Temporal Server, which is comparable to the React runtime that you might see. Then there's DevTools, which is the UI that you might want to inspect the state of things. And then the SDKs, which is what you use to code. So I think all those are really comparable to what we have in React. And having been in the React world for a while, like it's really amazing to see the analogies that we have exactly the same thing. For me, the really sort of the seal of approval comes from Mitchell Hashimoto, who created HashiCorp, saying that without Temporal, we would have spent a significant amount of time rebuilding Temporal, which actually to me is the best form of validation because Mitchell is one of the best developers in distributed systems, and he says it's hard, and he says we did it. It does it well. So I think it's a pretty worthwhile thing. All right, enough social proof. You want actual facts? I would just give it straight to you. So because your workloads, like the YouTube encoding or like the Uber journey, again, and this technology was developed by Uber, is long running and it ties together multiple services. You want to standardize timeouts and retries, and you want to make it easy for every team to have production grade retries and timeouts. Because this work is so important, you must never drop any work, you must log all progress. In other words, you must use event sourcing. And then finally, because this work is so complex, you want to use generic programming languages instead of domain-specific languages. So you want to model dynamic asynchronous logic, and then you want to reuse, test, version, and migrate it. So that's the sort of the pitch in one screen. But I'll just break it down for what it means, and then we'll go into a demo. So to me, I think the closest analogy to React is the programming model, because React spends a lot of time on API design. And in the workflow orchestration world, there are a lot of JSON or DAG based domain-specific languages. So you write a bunch of JSON, or you do boxes and arrows, boxes and arrows, boxes and arrows, boxes and arrows. Sometimes you even write XML, which is very interesting as well. What I find with all these is that they're actually really good for manipulating visually, but they get very tricky when you need to do programming language constructs like variables, functions, loops, branching statements, and all the things that we've invented in programming languages over the past few years. So if you use just JavaScript or just programming languages, you have all the tooling available. You can use all the libraries that are available. You can use all the testing and code version quality controls available. If you write your own, you have to rebuild all this dev tooling from scratch for yourself. So that's essentially what this is. Here's an example from one of the big clouds, where this is their workflow orchestrator model, where you write JSON, and it's really hard. It actually goes off the screen. I couldn't really fit everything on one screen. And with Temporal, it's literal just JavaScript. You call an endpoint, you use the result endpoint to call other endpoints, for example. It's a very simple example, but inbuilt here is default retry policies that have been worked out. So both of these handle reliability on Rails. It's just we defer in the programming model, and the engineering that it takes to maintain one of these SDKs is, I'm learning, it's very, very immense. So it's really interesting. So again, back to the core principles that we talked about earlier on from React. React decided on using a framework, decided on correctness, and decided on a programming model. And Temporal, in a very similar way, the developer writes workflows, and then the Temporal core team writes the orchestrator, which is Temporal server. The correctness level, in terms of correctness, React insists on functional programming, Temporal insists on event sourcing and deterministic workflows. And then programming model, you want just JavaScript or just programming languages, not any custom DSL syntax. So the final example that I'm going to motivate which is like, I've been trying to progressively reduce the complexity of my examples, right? So we went from Uber, which is like a super long running, a lot of humans in the loop, to YouTube, which is not so much humans in the loop. You upload it once and then everything else takes over from there. Now I just want to build one feature, which is a one-click buy button. In React or in front end, it's actually super easy. It's a button. It's the literal simplest thing you can possibly do. You put an on-click handler, you're done. If you want to do a one-click buy, you do a set timeout, and then say like, okay, if you want to cancel this within some window, with Amazon is 30 minutes, we can cancel it. But if you want to persist it, imagine if some person clicks, closes the browser, and then changes their mind, opens the browser again, and it's gone. You're screwed. You don't have any other way to implement one-click purchases. You need to implement timers on the back end to do this. And so that really drove home to me, because Joe Spolsky, I was watching this old talk from Joe Spolsky, where he talked about the engineering for the one-click buy button. And I put it up on my YouTube because this is such an old talk, and I was afraid to link to the timestamp. But you can check it out. It's just a 3-minute video where he tells the story about how Amazon moved from shopping cart to to a one-click buy. I mean, they still have a shopping cart, but it's that important, because in online e-commerce, actually, even up to today, the abandonment rate for shopping carts is 70%. So imagine if you implement this one feature, you improve your sales by, I don't know, what's the inverse of 70%? 3 times. That's really amazing. So I think it's just fascinating, and there are a lot of, and it's not just about shopping carts. It's not about Amazon. It's not about one-click buy. It's about user experience. It's about making things easy and intuitive, and turning things, and that often involves turning synchronous things into asynchronous things, and then persisting them so that they persist in the background. So I have a little demo here. I'm going to go really, really fast, but you can check out the code in temporal.io/samples node. The specific path is here, but it's basically a Next.js demo, where I have a Next.js folder here. This is going to be pretty standard for a lot of React developers. Hopefully you're familiar with Next.js, so you can learn it. It's got some pages and an API routes where I have serverless functions that call and send signals to my workflow functions. I have also a temporal folder where I have written my workflows and activities. The activities are just little logs, obviously, because they don't interact with any backends, but they could. And then the workflow it coordinates the state in the background of all of these. So I can show you the code, but essentially I kick off a one-click buy. with a purchase, and then I set a timer and promise a race with a 5-second wait. So if I receive a cancel signal during that timer, then that cancels. If not, it goes through and the purchase is confirmed. Obviously, I can increase this thing. And what's fascinating about Temporal is that every single step is persisted and automatically saved. So in other words, I can sleep for 30 days, I can sleep for a year, I can sleep for 5 years. And it doesn't matter because it's all persisted and wakes up automatically. So the compute, this serverless function can die, the worker or Temporal server itself can go down. You can just bring it back up again, and it carries on as though nothing happened because of event sourcing. So I'm gonna go ahead and run this. I think it's Yarn Dev, live demos. I'm always stressed out by live demos. Okay, I mean I did test it before the talk. It's just that whenever I'm streaming, like it adds an extra latency thing, and that goes haywire. So let's see if I have this demo available. All right, so I also want to pull this out, which is the UI layer. These are my test runs. But I have here a one-click purchase UI, and literally I want to implement this without a shopping cart, but I want to be able to cancel within some certain amount of time. So if I click buy, it sends a workflow, and that workflow starts in the background, and it's running, right? It's waiting for that timer to proceed. So I'm going to hit the timer, and you can see that the timer started and the timer ended within that 5-second window that I specified. Obviously, I should make it longer if I really wanted to show this along the way. This says this is purchased, and we can and now we've confirmed it. But if I ever want to click buy and then I can click to cancel, that also fires off a different workflow where it sees that it receives the cancel signal from me. So I signaled it to cancel, and that's a very useful model as well. So this actually shows off a lot of the core principles of Temporal, which is you kick off a workflow, you can set durable timers, you can send in human signals, and you can get out data as well with queries. And so there's a lot of interesting elements behind that, but that's the core demo that I wanted to show off. So maybe I'll write a YouTube example and then I'll go on to an Uber example and be a billionaire. So ultimately, I just wanted to recap again what we covered. We covered components, we covered architecture, and we covered time. And these are all the three elements I wanted to compare React and Temporal and explain a little bit of how we think about doing the hard parts of making clones of very popular projects. It's a little bit like, why is it so interesting? It's a little bit like the Crabs story. Obviously the founders of Temporal are not front-end developers. They didn't even know React at all, but they independently evolved a lot of the same principles. And I haven't even gone into like the full comparison. So we talked a little bit about deterministic functions and local state and composition, but we haven't talked about normalization and how that compares. DevTools testing is also a super interesting thing, as well as the central runtime. So there's a lot here, which I just am fascinated by, and I'm obsessed by applying the lessons from React to things that are not React. And I think overall, when I asked my CEO, like, what is the core message that we want to deliver, is actually about enablement. Like, we enable people to do things that they're not formally trained to do because we wrap it all in a central runtime or a central framework. So I always love the Alfred North Whitehead quote that technology or civilization advances by extending the number of things that we can do without thinking about it. And so for me, my version of it is that B2B software advances by extending the number of jobs we can perform without formal training. And the message overall here is that Temporal lets backend developers or just general full stack developers do distributed systems right. So that's it. I blasted through that. I only took 26 minutes, which is really great for me because I was worried that it would take 50. And I'm happy to answer any questions. You can hit me up on Twitter @Swyx. You can read my long form blog post about why Temporal. And then you can join our mailing list, YouTube, or Slack. Thank you.
All right, thank you very much, Finks. I think that was really, really nice, and you did went through that quite fast. From what I see in the comments, people love the live demos, right? They were
live demos because I could fail. Because I could fail.
It's always like that. So yeah, really, really nice. Thank you for the presentation. I'm not sure if anyone has a question for you. But in any case, if you want to reach out, Sphinx, follow one of the links he just gave you, or on social media. I think you can reach out to him directly, DM him any questions. I think he's open and up for that. With this talk, I think it's actually the last talk of the event, and I want to thank everyone for joining us. And thanks to everyone. Thanks to all the speakers, of course, for being part of this event, React Day New York 2021, and the sponsors. I think this would be good afternoon, I guess, or good night, depending on where you are in the world, right? And one wish that I want to say is, like, hopefully next year we'll be able to meet each other in person in New York or in any other React event, and have a blast there as well. So big thanks again to all the speakers for taking the time to get all of the information condensed and ready for us to see and view it in such short times. And yeah, I wish everyone a great day or afternoon. And that's pretty much all I had to say. Thanks again, everyone, for joining. Thank you, Sphinx, for the awesome presentation and for the awesome content. Yeah, have a good one,
Awesome.
everyone.
Yeah, bye, everyone. Enjoy. Thanks for having